manga muchizviziva here kuti maxutra ine mitsetse yakakurisisa. Vari kutengesa zvakachipisisa kumaxutra inhaka yedu. Maxutra unoziva kutenga, tenga unanzolelo pachindevere, tenga nehungwaru pachikaranga. Munhu anotenga zvakangwara kunanga pamaxutra woona bhodhi riripo wobva waterera zvizhinji pamumanzi. Maxutra nhaka yeZimbabwe.
Right, so I welcome you again to the part 2 of what we were discussing about last time, which is what is not so popular, load shedding. In the previous section, I had not given really the connection between a power system network, the power system performance, and the load shedding that I wanted to get to. So I gave an example of a car going downhill and uphill, trying to maintain 100 kilometers per hour. Then I also gave an example of a 200 watt generator going off suddenly due to its own protection or due to a fault scenario, such that the resultant would be loss of 200 megawatts from a system which was 1,500 megawatts, 1,500 megawatts balanced, with the 500 megawatts under load shedding, but planned or scheduled load shedding, where clients or customers connected to the system would have been pre-warned that you are not going to have power during this time, from maybe hour ending 9 to hour ending 10. Right. So we want to continue from there. We want to continue from there to continue to conclude our story. Right. So I talked about load dispatch centers as doing opposite of what actually the majority of people think. The majority of people think that the load dispatch centers are there to do load shedding or to shed people, especially the time that they want the power the most, which is morning peak and evening peak. And I'm here to say or to give a background of what exactly happens and why it happens. Right. So a generator has been off. 200 megawatts is off. I gave an example of a welding machine that if you've got a welding machine, you are connected to the generator and they are balanced. If you connect the second one, the generator will tell you that I'm now overloaded by the sound. So if you don't remove the welding machine, the second welding machine, the generator will stop, will come to a standstill. So I want to give a small technical background of why it happens like that. And I want to relate to the car which is moving, going downhill or uphill or flat on the road. To start with, I'll start with a car that is running flat on a flat road with forces, drag force and friction being balanced by the fuel that is being supplied through the accelerator. So the motion is balanced at 100 kilometers per hour, the road is flat, so the amount of fuel consumed is constant. Right. These are the people in the same house cooking, but have agreed that we are going to use 2 plates each. and no oven, no other 2-plate, assuming a 4-plate stove with 1 oven. Right. Now, these people are communicating, but then we gave a scenario where these people are now in different towns. They don't know each other, they can't communicate. Right. So these people are in different towns. So it means they can't communicate because they don't know each other. There is no means that they can now coordinate. So we said that's where the load dispatch centers come into play. So the load dispatch centers now are going to say, okay, here is a scenario where our load is balanced. What is being consumed is equal to what is being generated. Like we said, that is the rule of thumb. I will keep repeating it because that's where everything is based on, technically. That's where everything is based on. Everything else is a resultant of the fact that power generated should be equal to power consumed. And it is unfortunate that at the moment storage is very expensive, and not only that, it is also limited in terms of capacity, power capacity or energy storage capacity. It is still limited. So we can't talk about storage at a great level at the moment. So we'll talk about these as available solutions to keep the power system stable. By stable, I mean to keep it running, supplying the client's loads, what it is supposed to supply. What is it that it is supposed to supply? This power has got agreed characteristics that it is supposed to be supplied in this form. Power utilities cannot just supply any power anyhow. There is a statutory obligation and requirement to supply correctly agreed power quality in terms of voltage magnitude and frequency level. In other countries, the frequency is 60 Hz. Then in other countries, the frequency is 50 Hz. The voltage in other countries is 110 volts. Then in other countries, it's 230 volts nominal. Then from that nominal, we'll have allowable variances. At this point, let me just digress a bit and talk about why in the communities that we live, people often switch off gadgets when power goes or when power is interrupted. The reason they give is when power comes back. Last time when power came back, my TV got bent or my radio just went quiet, etc., my bulbs, a lot of theories. They are not far from the truth, because imagine if you are starting a car and you want to start movement. The smoothness of the starting of that motion is very difficult to maintain. The point where you reach the frictional point, and from that point the takeoff speed is often a characteristic of the driver. How much the driver is used to the car. Otherwise, they will be, either just speed off, or the car will shut down, start again, shut down, just like what learners experience. enough of that digression. So that happens also within power networks. At the moment of switching on, the load dispatch centers are not in view of how much stoves were left on, how much of the lights were left on in on position, what other loads, what motors were left in on position, whether by mistake or by planning. But at that moment of switching on, the load dispatch center is not aware of that information because the system is off. It will only get to know after the moment of switching on. So at that moment of switching on, the power may come slightly unstable, slightly outside the range which is acceptable by the gadgets or the appliances that are used by customers. The appliances come with specifications also. If you were to check at the back of the appliances, you will see a nameplate. A nameplate retaining the specifications of the power that particular TV or light or stove or iron is supposed to get from the power utility for it to function normally, for it to give its expected design performance. Otherwise, if the voltage is too high, it may generate excessive current flow, or that may lead to insulation breakdown, overheating, and can actually get burnt with the time, or it can shorten the lifespan. So yes, to an extent, it's correct. Only to systems that have got a problem of power cuts, unfortunately. Those with the systems that have got little power cuts normally do not experience, but still they experience surges. Surges are a characteristic of switching and so many other things, lightning and so forth. So no power system is immune from such kind of power quality problems. All power systems experience that kind of problem. Right, coming back to the issue of the power mismatch. So we said, I said I want to describe the effect of load or the effect of your appliances to the running generators. When you turn on your stove, what is it doing to the generator? And I said I want to relate this to the movement of the car, fuel supply and brakes. So if you turn on the stove, for example, what that stove is doing to the generator, picture it as if it is applying brakes. Picture it as if it is applying brakes. So as more stoves get connected, you are applying more brakes to the generator which is running, or to the generators that are running. So if a car that is in motion, you keep on applying brakes, that car will come to a point where it will come to a standstill. It will stop. But if it is downhill, you may apply brakes, but the motion may remain constant because there is now another factor that is pulling the car, which is the gravitational force. So the amount of brakes that you need to apply now, the amount of brake force that you need to apply now will be different from a flat road. How is that relating to the power system and the load? At night, people will start to sleep. So they will turn off their lights, their television sets, their stoves, and some light industry will shut down. So the effect is such that those brakes that would have been applied during peak will start to be removed, slowly. So if you remove brakes, the car will tend to gain speed. So the generators too will start to gain speed. But do you want to gain speed downhill? No, because you want to maintain your speed. Otherwise, the car will run to the speeds that are not acceptable. So, as people continue to disconnect their appliances from the system, the generator will tend to speed up. So, the automatic generation control system will instruct the guide vanes that allows water, if it is a hydropower station, to get to the turbine, to close it accordingly, so that the water that is coming to hit the turbine gets reduced and reduced smoothly and slowly. And this is an automatic process. The gates will close so that the amount of water that is coming and the energy that is now converted from that water becomes less and less and less to match the remaining load when people are sleeping. So in most cases you will find that power will be available every day at night because people are sleeping, there is no power usage. Now we sleep. Tomorrow, 4-5 a.m., people wake up. They start to turn on their stoves, their lights, they are cooking, they are preparing, Now, what are you doing to the generator? As you turn on your stove, you have applied brakes. So, where do we get the force to push against that brake that you have applied? The automatic generation control allows more water to come through to push the turbine. Because remember we said you are applying brakes, so we need a force that is opposing that. Because remember, we can't, or the utility cannot stop the activity of the connected load. The connected load in view of the power utility is something that I could relate or describe to as the disturbance in a control system structure. The disturbance, that signal or that activity which you can't control. You can't control. What you can only do is to predict it over time, because statistically you collect data, or you would have collected data such that you already anticipate that kind of behavior, depending on whether it is a Monday, it is a Tuesday, it is a Friday, it is a Saturday, it is a Sunday. The behavior is different. So collecting that kind of data will make you or will make your predictions more and more accurate and precision becomes high with more data as well. So we are assuming a system that would have worked for so many years with the power utility collecting data, hence being in a position to do short-term operational forecasting and then remedial actions. If you forecast and you see you've got a shortfall, you buy from the connected countries or from the markets, just like people buy money and sell money on the money market or stocks on the stock market. Same also happens with the power. Power is bought in real time to close those mismatches that would have arisen from unpredictability of the performance of the network. Now, so people keep on turning on their gadgets, and the effect on the generator is more and more breaks. Now, let's come to a point where we would have opened wide the guide vein and all water is allowed to come through. But people still continue to turn on the stoves. Now there is a shift in the scale. The load is becoming more than the generation, and we don't want that. Because if we continue with that, the generator will come to a standstill because you are applying brakes with no opposing force to keep its motion. It's just like a car. If you were to press brakes and equivalently press accelerator, that car would move as long as it has got fuel. It will move. The engine will pull through, although with more losses and more, damage, but it will move. So that kind of scenario is the same. We are saying, so we need a way now of balancing off this excess load. How do we do it? Generation we've increased, we've come to a limit. We can't increase anymore because we no longer have the resources to convert. In other words, all the water that is supposed to come is coming, all the steam that is supposed to come is coming, but we've reached a limit. So what solution becomes available is to stop the load from rising, and that is now called load shedding. So whatever rise happens is trimmed off the system. Whatever rise happens, trimmed off, and maintaining this balance, load and generation. That is about load shedding. It can be automatic or manual. Automatic is when the control system is sensing that the generation is now less, so it is pre-programmed to cut some sections of the load on its own. It will send a signal to say trim these loads immediately, so the loads will be trimmed, so that action is faster. Manual is when a person is sitting and seeing that now my system is in mismatch, so I need to trim the load. So they do it physically on the system still. It's more or less the same equipment that is used to do or to achieve the same goal. That is about load shedding. Now, another addition to that is the background here is we are doing energy conversion. We are converting from one source to another and back to another depending on the type of load. Does it require rotational energy, kinetic energy? Does it require heat energy? Does it require light energy? So we are just converting. Now we are at the load. We talked about how to bring it from the power station to the load. But at the load, there are other physical or atmospheric, let me say, there are atmospheric conditions that also determine or that are an input to how much is supposed to be taken off. Let's say in winter. In winter, the temperatures are very low. Say, let's give figures, 0 degrees. And then in summer, let's say 30 degrees. So, for example, a body of a human being operates optimally at 36 to 36.5 thereabout degrees Celsius. What it simply means is the functions of a body, they are efficient at 36 to 36.5. I'm not very fine with the actual figures, but I know it's 36 to 36 point something, 0.5 thereabout. The operations of the body, digestion, and so many other things are efficient at that temperature. So what it means is, if the atmospheric temperature is at 0, the body, yes, it will do its function of correcting that temperature, but it's better with the heating. Let's go to other activities like cooking, for example. Water boils at 100 degrees Celsius. In summer, it is starting at 30. So you need to heat it from 30 to 100. So that's 70. You need heat that is equivalent to reaching or to raising temperature of the water by 70. But in winter, you are starting from 0. So the demand for energy becomes more because you've got this state that you have to do first before you actually start if it was in summer. Not only that, there is another energy conversion that is happening that you don't want or you are not caring about, which is heat loss to the environment. That is still energy. Although it is not directed to what you are heating, but it is being lost to the environment. Hence, usually the kitchens, the kitchens of the restaurants are usually very hot places. Because of the energy loss, it's not by design that those places are hot. No, that energy is actually not intentional. If there was a way of collecting that energy and directing it to the actual target, which is supposed to be heat, then it would actually, the effects of load shedding would be less. Hence, the technological advancement in terms of that targets prevention of energy losses. There are various energy losses. Light, for example, if your light is intended to light a room and then it goes outside, that is loss, because you are not intentionally putting it there to light outside. So lights, you know that lights are sized in terms of watts. So in other words, that is power, and now if you power times time, that is energy. So with that, I think we've talked about I think I've addressed the questions that are mostly or usually asked by people. And if there is something that I have omitted and you feel it's supposed to be answered, comment section, ask as many questions as you may want. Those that I can answer, I will answer in the next video. Those that I can't, I will keep researching for answers, but I will try to answer the questions. Otherwise, for now, thank you very much for watching, and we meet next time. Please, you can share, you can like, you can comment. Thank you very much.
Max Ultra Energy, reliable in solar system. Kazona panex dopako panechieza usazoshamisika kana kuvunduka kazhinji tinogara tichitaura nezva Max Ultra Energy Solution. Shasha power ring Max Ultra Energy Solution.